Здравствуйте.
Он смотрится вообще как вот итальянец, я думаю, так смотрится. Видите, какой кабинет у него?
Доброе утро. Всем.
Доброе
Музей,
утро.
не кабинет, а музей. Не кабинет, а музей, да. Так.
Здравствуйте, дорогие коллеги. Здравствуйте, Скрипач.
Асиль Сереговна, можно начинать, да?
Профессор Бумитхан подключился.
Да, все. Good
Да,
morning, профессор Буми. Good morning.
Good morning.
Good morning.
Good morning.
Professor Bumi, today will be work from Delhi.
Delhi, yes,
Right?
yes. Yes,
Да.
yes.
It's capital of India.
Okay. Good morning to everyone.
Good morning. Доброе утро, профессор Буми. Асиль Сереговна, можно начинать?
Да, можно начинать.
Все, начинаем тогда. Dear colleagues, due to the fact that I am chairman of dissertation committee council, but also I am supervisor of PhD students of PhD Буранбаевой А. So today's defense will be carried by Deputy Chairman of Dissertation Council, Dr. Shahmov Jambulat Anwarbekovich. So please, Dr. Jambulat.
Good morning, dear colleagues. Today we have, I want to inform that the meeting of the Dissertation Council is being recorded. On the basis of the attendance list, all 7 members of the Dissertation Council are present, including permanent members of the Dissertation Council, 3 people. This is Professor Askar Rusupekov, Chairman of the Dissertation Council, Doctor of Technical Science, and me, Shahmur Janbulat, Deputy Chairman of the Dissertation Council, PhD, Associate Professor, Tulibekova Assil Serikovna, Scientific Secretary of the Dissertation Council, PhD, Associated Professor. Also, we have today 4 temporary members, 4 people. Professor Adimulam Buminatan, PhD, Professor of the Department of Civil Engineering at the Indian Institute of Technology, Madras, India. Kotov Pavel Igorovich, Candidate of Sciences in Geology and Mineralogy, Chief Manager of the Scientific of the MGU, Norilsk Nickel, Norilsk Russian Federation. Urazova Dinara Kazbekovna, PhD, Associated Professor of the Department of Industrial, Civil and Transport Construction at the Toregelov Pavlodar State University, Pavlodar, Republic of Kazakhstan. Diakonov Ivan Pavlovich, Candidate of Technical Sciences, Associated Professor of the Department of Geotechnics, St. Petersburg of Architecture and Civil Engineering State University, Russian Federation. Present official reviewers, we have 2 present official reviewers. Professor Dusimbin Fizim Nasivich, Doctor of Technical Science, Construction, the General Construction of the Kazakh Leading Architecture and Civil Engineering Academy, Almaty, Republic of Kazakhstan. Kudyavtsev Sergei Anatolievich, Doctor of Technical Sciences, Professor, Head of the Department of Bridges, Tunnels and Underground Structures at the Far Eastern State Transport University, Khabarovsk, Russian Federation. There is a scientific advisor of PhD students, Rusupek Askar Vakparovich, Chairman of the Dissertation Council, Doctor of Technical Science, Professor and researcher of the Department of Construction of the Gumilev Eurasian National University. We proceed to registration in the Smart UNUKZ system. The word is given to the Scientific Secretary, Assil Serikovna.
Okay, thank you. I ask the members of the Dissertation Council and reviewers to register in the Smart UNU information system. Everyone has instruction on how the system works. It is necessary to select a PhD student Буранбаевой А from the list, click the Conduct Defense button, then the Register button. So please Now the registration is open.
Okay.
Diakonov Ivan Pavlovich has already registered. Another members, please. Professor Rusupekov, Professor Shahmov, Dr. Urazova, Professor Kudryavtsev, Professor Buminat-Khan. Рецензенты только.
Там ссылка какая была?
smart.enu.kz.
Smart.nu.
Cecilia Yakovna, does I was registered?
Yes. It's
Okay,
thank you.
Smart.enu, да?
Ага, .enu.kz.
ENU, KZ, да?
Сейчас
Z.
я поделюсь с вами экраном, просто чтобы показать, как
Это у
пишется.
меня.
Вот вверху Smart enu kz.
Сейчас. Сейчас что-то у меня. Smart ENU, KZ, да? Не получается. Сейчас.
Вы пока регистрируйтесь, я сейчас еще в технический отдел позвоню, немножко есть. Одного человека я не вижу.
Я чуть не могу включиться.
Ну,
Да.
Я зашел. Вот добро пожаловать, Сергей Анатольевич, есть.
пошел. Так. Идем. Куда мы идем?
Появился, да?
Диссертационный, да?
Сергей Ильич, я появился там, нет?
Диссертационный
Партия
совет.
доктора.
Идем. Потом
Доктора.
идем. Так, смотрите, Оскар Павлович зарегистрировался. Иван Павлович зарегистрировался. Шахмов Жамбулат Анубекович зарегистрировался. Кудрявцев Сергей Анатольевич нет. Динара Казбековна еще нет.
Вот
Где
у
вас
меня
зарегистрировать? Какой документ?
Сейчас профессор
Вот идет
Буйматхан.
регистрация.
Я.
Just moment, I call to...
Сергей Ильич, у меня вкладка
technical
регистрация
department.
не появляется.
One minute.
Я регистрируюсь, идет регистрация.
Сергей
Кудрявцев тоже
Ильич,
идет
у
регистрация.
меня нету вкладки регистрация. Я вот сижу в докторантах.
У меня тоже нет.
Идет регистрация написано и все.
Кудрявцев также.
Я зарегистрировался или нет?
Сейчас, подождите, Дим Васильевич, она сейчас, Сергей Ильич, разбирается.
Там долго что-то
Это
регистрировать.
вот, перипетии нашего вот этого секретного голосования, да, секретного голосования.
Ну, там у меня крутится, что регистрация идет, а не зарегистрировано еще, по-моему.
Уважаемые члены, немножко техническая ошибка, поэтому регистрацию я завершать пока не буду. Вы будете регистрироваться, пока идет защита. Сейчас будет добавлены еще временные члены, там техническая заминка идет. Поэтому мы сейчас продолжим. Я вам напишу в WhatsApp, чтобы вы дальше продолжили, те, кто сейчас не прошел регистрацию. Сейчас начальник отдела технически подправит. Слышно, да, меня?
Можно, да? Продолжать можно.
Да,
Нет.
можно продолжать.
Продолжать можно, да.
Можно.
Жамбулат Анурбекович, вы можете продолжать тогда. Жамбулат Анурбекович. Не слышно, да? Жамбулат Анурбекович, вы можете продолжать, да?
Да. Все хорошо. Так, технические неполадки, да, у нас в ВУЗе. So, okay. Unfortunately, they have some technical errors, mistakes. So we shall anyway, we could continue. There is a proposal to open a meeting of the dissertation council. The decision is made by open vote. Are there any other suggestions for open voting? No, yes. Okay. Who is for? Please vote. So, yes, okay. Against? No, yes. Okay. Abstained? Okay, no. Adopted anonymously. So allow the meeting of the dissertation council to be considered open. Let's start the work of the dissertation council. So today on the agenda, we have defense of the thesis of a PhD student of the specialty 8D 07329 construction. Айгерим Муратовна. On the topic artificial neural network in basement slab monitoring using distributed fiber optic sensor for the degree of Doctor of Philosophy PhD in the specialty of civil engineering construction. Each member of the dissertation council is preliminarily presented with an annotation of the dissertation in 3 languages. The dissertation is being defended for the first time. The word for announcing the main content of the documents submitted by the applicant and their compliance with established requirements is given to the academic secretary Тулебекова Асель Селиковна.
Okay, thank you, Professor. All documents according to the list of documents submitted by the applicant for a degree to the dissertation council in the case of Буранбаевой А are available and meet the established requirements. Reviews of scientific advisor and reviews of official reviews are available. The draft conclusion of the dissertation council was assured to all members of the council. Thank you.
Okay. Do the members of the dissertation council have any questions for the academic secretary of the council? Okay, if no questions, in the case.
So, Dr. Jambulak,
Yes.
So better if Professor Дюсембаев and Professor Bumi stop микрофон, да.
Okay.
Закроют микрофоны. Да. Чтобы слышимость хорошая была. Сергей Кудрявцев also.
Oh, okay, I understand. In the case when there are questions, time for question and answer is given. The words for the report is given to PhD students Буранбаева Айгерим Муратовна. So please, Айгерим Муратовна, you shall give us presentation.
Thank you, Жамбулат Анурбекович. Hello, dear members of the meeting. I would like to present to your attention a dissertation work entitled Artificial Neural Network in Basement Slab Monitoring using the Distributed Fiber Optic Sensor.
Presentation should also open the presentation.
Not open presentation.
It's not opening. We didn't see. We don't see presentation.
And now?
Okay.
My scientific supervisor is Dr. Professor Askar Rusupekov, and foreign supervisor, PhD Associate Professor Goalin D. And firstly, I would like to give you a brief summary of my report. It includes content, purpose, and the main task of the research, problem statements, proposing discrete fiber optic strain sensing system, methodology for numerical analysis, experimental research methods, field results, modeling and analyzing system using beam, recommendations, and conclusions. The purpose of the study of international experience to perform numerical analysis of slab expansion to define the minimum gauge length for the fiber optic cable, numerical modeling of the concrete raft to determine the vertical and horizontal displacement, numerical modeling of concrete raft, to design of discrete fiber optic strain sensing system on the concrete raft surface to substantiate the obtained strain during monitoring with the fiber optic cable. The main task of this work is to develop a discrete fiber optic strain sensing system of foundation, which allow the continuously monitoring the foundation slab in order to avoid the appearance of cracks in the foundation slab and adverse effect during the operation of the building. And thirdly, to improve the reliability and safety on the project through the timely identification of critical points of determination, and to receive data from sensor and integrate it into the building information modeling system, which in turn makes it possible to process a large amount of data to make correct and quick decisions over the entire life cycle of the object. Deformation is one of the most commonly monitored parameters in structural health monitoring system, and deformation-based approaches were among the first to be studied, applied in structural health monitoring. Fiber optic sensors in civil engineering have recently become increasingly popular. The advantages are their small size, good resolution and accuracy, and excellent ability to transmit signals over the long distance. This is especially relevant for the construction of high-rise building, an example of which monitoring is presented in this study. And the main goal of this work is to combine data from discrete fiber optic sensor to make faster and more confident decision when detecting damage than is possible with only one sensor. Engineering design standards are often based on limiting the deformation and stress they occur in structure. This is important because it is a deformation that is a measure of how close the structural material is to the strength and therefore indicate the potential extent of damage that has occurred. Knowing the continuous deformation profile helps to detect problems such as deformations, twists, and unevenly distributed ground structure interaction forces due ground the heterogeneity. And DFOS is chosen to perform this task. The optical fiber used in the system provide more accurate data than other sensors. The sensors are connected to the device from which the light waves through the return optical fiber and delivered to signal pre-processing device. In this work, The following research methods were used in this study, like literature review, numerical analysis of slab expansion, modeling of concrete raft under full load, and experimental testing on the construction site. And first, methodology for numerical analysis. The numerical simulation assumes that the reinforcement coverage is 40 millimeters. For simplicity, it is assumed that the center of action of the reinforcement is 50 millimeters inside the surface of the concrete. Any concrete outside the boundary formed by the action center is ignored to simplify the mesh. According to the numerical simulation results, a gauge length of 2 meters is sufficient to prevent fiber optic fracture. And this is a value that should be chosen for the design. The stride test of minimum required deformation resolution for all expansion cases is 22 mu epsilon. In the case of 3.8 meter thick reinforced raft that requires strain resolution for various expansion events, and detectable surface strain limit is 51 mu epsilon. If this limit is exceeded, additional surveys are required for a local diagnostic survey with concrete sampling and strain testing as a part of the diagnostic survey. Numerical modeling of concrete raft using the plug was using PlugSys 3D software to determine the horizontal and vertical deformations of the raft was performed. Modeling was designed for the 3.8 meter thick raft with axis 12 to 19 in the Y direction and axis C to K in the X direction. This figure shows the loading system on a reinforced concrete square section raft podium with the side length. The load transmitted from the columns and floor level B4 was represented by a point load. And from the wall of the core and building is a linear distributed load along the axis wall. And the next experimental research method was in Abu Dhabi Plaza building complex. The site of the experiment in the basement on the tallest building complex in Central Asia, 320 meters tall. Engineering geological profile of construction site we can see in this graph. The soil conditions are presented in this table. We can see the properties of the soil, clay, sand and gravel, silty clay, rock debris, sandstone, and hard stone. The raft construction. The complex consists of several buildings where fiber optic cable monitoring was conducted in 3 of them, Block R, Z, and Y. Block R is the tallest building in the complex and is 75-story residential building with a 4-story underground parking lot at the base. Now let's move directly to the distributed fiber optic sensor system. The proposed DFOS system consists of a grid of fiber optic cable attached to B4 plate and connected to an analyzer located in a temperature-controlled room at B1. On the B1 level, there is an analyzer monitoring system for temperature and strain data collected via the distributed fiber optic sensors. The proposed location of the fiber optic cable on the base plate is shown in this graph, in these drawings. The drawings show the bending radius of the cable at the bent location as 600 millimeters. The proposed layout is based on an 8-meter grid spacing, but there are areas where the spacing is much greater than 8 meters, especially around the core of R block, located in the center of the R block raft. Internal walls prevent the cable from running straight through the core, and wider grid spacing inside the core is allowed to avoid the complicated center paths. For any point on the slab inside the core, the greatest distance between the point and the nearest fiber optic cable is approximately 6 meters. After our block, the fiber optic cable was laid in the center Z block building, and then go to the Y block of the central part, after which it return to the R block, but already in the form of a zigzag in the direction of X. The dwellings in the Y and Z blocks are built adjust to the ramps leading to B3 level, and laying the fiber optic cable avoids the ramps areas. We can see lengths with directions shown in this table, length of the cable and direction. The analyzer must operate it under certain environmental conditions, and therefore must be located in a temperature-controlled room. The analyzer room will also house a logging system and computer needed to communicate it with high-speed internet, so the room must be provided with uninterrupted power and high-speed internet connection. In this picture, we can see a monitoring room with application in the construction site with typical analyzer. In this figure, we can see the cable installation in the basement slab drainage system. The cable repairing work and installation work was organized and carried out by SmartTech system and me. Field results. The upper figure, this figure shows strain fluctuation along the fiber optic cable from 115 meters and 615 meters in the Y direction under block R. The vertical axis represents the strain in the cable in mu epsilon, positive values in tension, negative values in compression. The horizontal axis defines the position along the length on the fiber. In this case, the position on the cable along Y direction in the basement raft of the high-rise block start from 115 meters, and the length is 567 meters. This graph demonstrates the results of fiber optic cable deformation for block R in the reverse direction. After bypassing block Z and Y laid in horizontal direction X1, X on the section from 3,521 meter and to 4,121 meter. Here, significant compression deformation are registered in the middle section from 3,695 meter to 4,100 meter, and significant tensile deformations in this area on the south side of the block R. As can be seen in this figure, the results fiber optic studies show an alternate of deformation sinks along the length of fiber optic cable embedded in the raft of the lowest level. This level is a B4 of block R. Compression deformation prevail in the central part of the core. In this zone, or increased load from the reinforced concrete load-bearing walls. The tensile strengths are most concreted on the extreme axis as well as near the joints of the column. The interpretation of the compression zones terms magnitude is shown next figure. We can see the tensile zone on the this one and in this figure. The fiber optic cable was laid in the base of the raft under the highest block R. The total length of the cable 4.4 kilometers, including strain and temperature measurements, fibers running parallel in one cable, of which 664 meters in the X direction and 567 meters in the reverse Y direction under the R block particularly. According to the results on the monitoring, the stress zone in the R block are evenly distributed values of minus 20 for minus 40 mu epsilon, with the slight predominance on the right eastern. Individual minus 40 and minus 60 mu epsilon spots we occasionally located along the outer counter of the building. While the central, northern, and eastern parts of the building show a more stable pattern of tensile stress accumulation. Local tensile strengths are most concreted over the extreme axis as well as near the column joints. Compression deformation prevail in the central part of the building core, in the zone of increased loading from the reinforced concrete long bearing walls. Fiber optic observations showed an increase in relative strengths near the zones of concreted loads up to 80 mu epsilon. It is 0.08 millimeter per 1 meter of length in the horizontal plane. Analyzing this figure, single scatter points of tensile strengths are located in the of the column and explained by the stretching of the upper part of the raft. The concrete at the column bearing points is subjected to compression dew point loading from the upper floors. The top layer of the raft in the vicinity of the connection between the column and the raft is subject to deflection. And because of the optical fiber is located in the upper layers, it experiences stretching in this place, but in the middle of the deflection zone, the cable is subjected to compression. In the middle part where the distributed load applied, the plane of the raft is uniformly compressed. And the next slide is a discussion of the numerical comparing analyzing of numerical analysis results and experimental measurements. The simulation results represent a general picture of the distribution of settlements in the building plan. They don't take into account local effects from the concentrated load from columns and core walls, and also don't detail the horizontal plane exactly with the points of dangerous tensile deformation are located. Since concrete doesn't work well in tensile, the local tension of concrete is fraught with crack information. Observation showed increased relative deformation near the zones of concrete loads columns up to 80 mu epsilon in horizontal in horizontal plane. As can be seen, fiber optic results show alternating strain sinks along the length of fiber optic cable embedded in the raft of lowest level before block R. Compression deformations prevail in the central part of the building core. In the zone of increased load form the reinforced concrete load-bearing walls. All buildings, properties, components, documentation, and the structural data must be accessible via by BIM model. The BIM model database is easily represented using the IFC standards to pass the exchange files like from sensors to system. In this research, foundation slab with the integrated fiber optic system sensor was taken as an example to show that the model facilitated the interpretation of data using and dynamic BIM environment. I have an internship program at the Kazakh Research and Design Institute of Construction and Architecture. It was 90 days. The result of scientific work we published in 80 scientific papers, including 3 publications recommended by the MES Republic of Kazakhstan and 2 publications in the international publications with non-zero impact factor, and a research paper in the proceedings of local and overseas international conferences. This is the implementation act of the work. 2 days ago, I returned from Turkey. There was the strongest earthquake in the last 100 years. Occurred in the southeast of Turkey. In the footage, you can see just only part of the destruction from the earthquake. As you can see, a very big, large rift has formed in this area. What I mean to say, is that in such areas, the buildings must be monitoring in order to understand the risks with the operation of the building. And technology allows to predict the life cycle of the building, and therapy avoid the grid losses because, as I said before, safety is the main task in the construction process. This is a building in Hatay province, Antakya city. It was 12-story, 250 apartments, residents built in 2013. But now we can see that every build is cracked. I was in Mersin, and fortunately, the city was in safe zone. But we can see in this slide the epicenter of the earthquake was in city and province Kahramanmaraş and Iskenderun and Antakya. Moving to recommendations, there are a lot of recommendations. I'm saying one of them. Based on the result of the study, We recommended the use combined strain and temperature sensors, which are designed to distribute monitoring of strain and temperature over long distance using Brilliant scattering. According to the numerical modeling, a gauge length of 2 meters is sufficiently long to avoid fracture of the fiber optic. The most transfer or minimum required strain resolution across all expansion events it is 22 mu epsilon. According to the fiber optic cable material properties, the maximum determined strain is 0.5%. Recommended to determine the optimal format for structural haze monitoring data storage in the digital database using BIM system, as it will help to increase the efficiency of monitoring further in operation to speed and decision-making time. There are main conclusions. First of them, fiber optics monitoring made it possible to provide actual results of strains in the upper layer on the raft at the lowest level before on the high-rise 75-story block of the Abu Dhabi Plaza building. The compression strains were observed over the entire area of the building with values minus 40 and minus 20 and minus 30 mu epsilon. Y direction and along the eastern facet on the block are in the building core with some points up to minus 60 and minus 80 mu epsilon. The tension strains are concentrated along the extreme axis of the building with the predominance in the southern part of the block R, as well as in the immediate vicinity of the columns in a range of 20 and 40 mu epsilon, with separate spots 40 and 60 mu epsilon. Individual patches of tension strains near the column have been explained by the increased detection of the raft under application of the concreted load. The axis of deformation of 600 mu epsilon in crack width exceeded requires a local diagnostic examination with concrete sampling and testing for strange characteristics. When a strain above 1000 mu epsilon, it is 1%, occurs, a basic structural analysis is recommended. Above 1500 mu epsilon, a detailed structural analysis is required. That's all. Thank you for your attention. My report is now concluded.
Okay, thank you for the report. I want to continue. What questions will be asked to the applicant? Questions can be asked orally or in writing form. So, if there are some questions, please. So, I have some questions. Maybe I begin. So, I want to ask firstly, why was in this building was the observation?
My observation is Abu Dhabi Plaza, yes?
Yes, yes, yes.
Because in foundation was going some water, and Arab Tech Construction decided that this building is needs observation of foundation, and to take some subcontractor like Smart Tech Technology, and it was during the time with my research work, and I participated this observation and did some commission tests and take data from October and to February month.
Okay. The result of the observation also included in your dissertation, yes, thesis?
Yes, yes.
Okay. I want to ask about the structure. How you estimate the condition of the structure? I mean, regarding to the cracking or so on. What was the condition and estimation of the underground structure which you observe?
We particular emphasis in obtaining the results with fiber optic sensors for high-rise building. We have two different tests for the wall. We performed for the measurements precision error once the entire installation, circuit installation, when it was complete, and there are one important factor causing precision error in the thermal shift in the electronic components within with analyzer, with equipment analyzer.
So, okay, and finally, what was your recommendations?
Recommendation?
Is it finished monitoring or not?
Not finished. Now monitoring is continuing and comparing data from last year's and today data.
And so therefore it is now no any recommendation for the for decreasing the cracks and deformations, defects, how to decrease the deformation of the underground part of the building, yes?
Yes, yes.
No any recommendations. So now it's continuing monitoring and recommendations. When will be the recommendation regarding to the what to do with this problem?
What to do with this problem? One of, as can I say said before, one of the recommendation, it is using diffuse system, because these sensors, the system can be using 70 years and we can take data all of the time and comparing these data and give these data for company who exploit this building for decision making. It is one of the recommendation. And second, I propose concept of BIM model, such I say, for comparing data, for saving data, and if maybe it needed after some years, it needed repairing works, we can take this data from this model. Arabtech was continuing these works. And third recommendation was observed over the entire area. And we need to see values, because values, it is very important in this case. If the values was from minus 20 to minus 40 mu epsilon, we can see it to continue the observed. But if the compression strains, if will be a minus 60 to minus 80, it is will be dangerous, because we need to some hard repairing works.
So, anybody has some questions? Professor
I
Kotov,
have.
Professor
Could I
Diakonov.
ask some? Yeah.
Yes, Professor Diakonov, please.
Yeah. Thank you for the great report and great research. And I have several questions about your research. First one, which uncertainty, which error of estimation of the strain result in this monitoring system? Which error of the estimation of the strain and stress in this monitoring system?
Which
Yeah.
errors?
Yeah.
Which errors? One of the it be these errors if the fiber optic is integrating to foundation system, to concrete system with some not so good if will be not so good environment. For example, water, when we doing the integration fiber optic cable, because we have some we will have not good datas. Why? The fiber optic sensors have some measurements. We can use 1.5% for these measurements, but it is more than 1.5%. These measurements is not so useful. This is one important errors in this system.
Thanks. And do you know there are a number of a large amount of monitoring system in the building site, geodesic system, and maybe I don't know, strain gauge and other. Do you know about this system, and did you compare your results and results with the other system of the other monitoring system?
I didn't compare it, because I know that in this building using just for foundation, because in this case we observed foundation. For foundation, constructor not used other systems, and the result didn't compare it.
It's very interesting that other system didn't use. I'm sure that in every site we use a geodesic system. It's prohibited. Didn't use it, but okay, it's very interesting. And about the Plaxis 3D, what assumption do you have in this calculation? And I mean, maybe about something about soil material or modeling construction because in your calculation you didn't modeling the construction of the buildings, but I think it's it will impact to the results. Are you agree with it?
The 3D Plaxis using for numerical modeling for determining the horizontal and vertical deformations of the raft was performed. And modeling was designed for the 3.8 meters thick the raft and we saw that it using for loading system on a reinforced concrete square section raft podium. Just for this task, we're using the numerical modeling.
Mm-hmm. Many thanks.
Thank you.
That's it. Yeah.
Профессор Шахмов. Профессор Шахмов. Селия, вы, наверное, продолжайте, Селия. Что-то у него там технический какой-то сбой, по-моему.
Yes, he has some technical problem.
Продолжайте.
So, dear members of the Dissertation Council reviewers, have any questions to applicant, to Буранбаева and Girim, please? Who wants to ask another questions? Please give me also, I want to ask you one question. Could you please explain about your future investigation regarding this theme, regarding this investigation?
Yes, I think if it's possible in future, I want to continue this work with realization beam model with integrating sensors, datas, and if it will be possible, I want to offer this system for other company for taking some experience, for taking some new knowledges. That's all. Thank you.
Thank you. I also wish you good luck to your future investigations. Thank you. Okay, so please, Professor Rambulat.
Yes. No any questions? Yes. No questions? So, okay, if no questions.
Okay, Professor Jambulat, your microphone is closed. Please open.
Yes, I'm sorry. Does anybody has questions? Professor Buminatan, Professor Kotov, Professor Kudryavtsev.
I think we move to a review of our scientific advisor.
Okay. So please, the word is given to the scientific consultant, Doctor of Technical Sciences, Director of the Geotechnical Institute, Professor of the Department of Construction.
Thank you.
Microphone,
Thank you,
please,
Professor.
microphone. Mhm.
Yes, thank you. Thank you, Dr. Jambulat, for giving to me talk about
Yes.
activity of PhD Буранбаевой. So I want to say for our group will be big challenges of investigations of especially behavior of Abu Dhabi Plaza, because it is 77th floor on high-rise building in Central Asia in this moment, and also maybe in some part of South Asia also. So these buildings was some problems because we have not only problem with foundations, we have some during time of construction also several times many fires, corruption, is Kazakhstan, sometimes like corruption, but we thinking about Kazakhstan, but Arab people also some corruption there. It is his client was Arabic company. But anyway, foundations was made by Turkish company, and after that we have some problem of water flooding inside of underground space, and also we have some problem of cracks and during time of exploitations in the developing of height of buildings. So after that we request our PhD students make some investigations together with Malaysian company and Australian company. This is company, was international investigations. So Dr. Aigerim made a very great job because it was from October until end of February and beginning and middle of March. So it's especially the cold time and the autumn time, not so cold. So we have in springtime. So we have make some duration of comparison of database. So anyway, it was very interesting for us because it is very interesting monitoring system, because we can make monitoring here and receive information in our department, in laboratory, and also in the Malaysian laboratory. So Aigerim, especially, she is a specialty information technology. She is graduated information technology. So before I am surprised how the American people received PhD after different specialties, coming to civil engineering, especially Professor Iwasaki. His bachelor degree is geophysics, master degree in the University of Berkeley, United States, civil engineering, and PhD in Kazakhstan in geotechnical engineering. So this time is Aigerim also made some heroic work, understand of mechanism of monitoring, especially high level monitoring, not only civil engineering issues, but also some technical issues. And Arab people listen her. I surprised that she was like foreman, not only investigator. She has 2 children and husband, very good mom, and also he control full Arab people. Controlling Arab people not so easy. I remember during time I studied in St. Petersburg. So she also produced many good published in the Q2. It is not so easy in the Applied Science journal. Also he published in several another GeoMat and also in our journals, our university, and the different conferences. She made very good report in the Turkish conference in the 1 year ago, and also she made good report in another conference like Finland and CIS countries. So I think she now work very well in Turkey. So she can introduce our technology for Turkey. You know, Turkey is now collapsed, 30% buildings in collapse, about 30,000 people dead. So you can help, she can help. So I think if we support of her activity, research activity, she will be continuously work, and during time of her work in Turkey, she has now good job in a good city without any seismic, I think, city, Meslin city, not so have, I think, is not so big seismic activity in soil ground. So I think it will be developed. And also, please, Aigerim, don't forget Kazakhstan, please, because we have also some problem of monitoring. So please support of her, if possible. Thank you very much for your attention.
Thank you, Professor Askar. Do the members of the dissertation council reviewers have any questions? No questions. In the case when there are no questions, time for question and answer is given. The word is given to the foreign scientific advisor, PhD, associated professor of the Faculty of Civil Engineering of the University of Technology, Mara, Pulau Penang, Malaysia, Ko Lin Di.
I'm going to read the main points of this review. Thank you, Professor Rambulat. The dissertation of Буранбаевой А is a research work of the current topic on the applicant of the artificial neural networks in the monitoring of basement slabs using distributed fiber optic sensor. The degree of novelty of which results and conclusion is wound up and lies in the introduction of a new method of monitoring the foundation slab using fiber optic sensor at the construction site. A significant amount of field and laboratory experiments with analytical processing was carried out to achieve the goal. In view of the above, I believe that the author research of the awarded of the PhD degree in the civil engineering, Dr. Goh Lin Di, Associate Professor of the University of Technology, Mara, Malaysia. Thank you.
Okay.
Professor Rambulat.
Do the members of the dissertation council and reviewers have any questions? Okay, no questions. In the case when there are no questions, time for question and answer is given. Scientifics, the file contents or the file content. So please, Asya Serikmana.
Okay, thank you.
So I think I understand no questions, so you could continue.
Thank you. The file contains the minutes of the extended meeting of the Department of the Preliminary Examination of the dissertation work of the PhD student Буранбаева А. So regarding this extended meeting, I recommend the dissertation of the PhD student Буранбаева А. on the topic artificial neural network in basement slab monitoring using distributed fiber optic sensor, submitted of the degree of Doctor of Candidate Philosophy PhD in the specialty AD07329 Civil Engineering for defense of the dissertation council, architecture and construction. Thank you.
Okay, thanks. Do the members of the dissertation council reviewers have any questions? There are no any other questions or comments. The word for the presentation is given to the reviewer, Doctor of Technical Sciences, Professor of the Faculty of General Construction of the Kazakh Leading Architecture and Civil Engineering Academy, Almaty City, Republic of Kazakhstan, Дюшимбаев Изим Насиевич. Please, Изим Насиевич.
Thank you. Review of Aigerim Буранбаев's dissertation. Title of PhD thesis: Artificial Neural Network in Basement Slab Monitoring using Distributed Fiber Optic Sensor. As you know, the review is based on the compliance of the content of a dissertation with certain criteria. So the first criterion, the thesis corresponds to the priority direction of science development approved by the highest scientific and technical commission under the government of the Republic of Kazakhstan. The second criterion, work does make a significant contribution to science and its importance is well discovered. The third criterion, a level of self-reliance is high. The fourth criterion, rationale for the relevance of the thesis is justified. The content of the thesis reflects the topic of the thesis reflects. Next, 2.3. The goal and objects are consistent with the topic of the thesis, conformed to. The next, all chapters and statements of the thesis are logically interconnected. They are completed, interrelated. 4.5, new solutions. Principles, methods proposed by the author are good and relevant in comparison with known solution. Its critical analysis is the fives criterion. 5.1, as a scientific result and statement is partially new. 25 to 75% are new. The next, 5.2, are the conclusion of the thesis new? Yes, partially new. Then 5 and 3, technological, economic, and material solutions are new and reasonable. Partially, about 75% are new. The sixth criterion. All major conclusions are on scientifically valid evidence. Seventh criterion. Seventh one. The statement proven, yes, it's proven. 7 and 2, is it trivial? No. 7.3, is it new? Yes, it's new. 7.4, level for applications. It's a broad. 7.5, does the article prove? Yes, it's proof. The eighth criterion, principle of reliability of sources and information provided. So, choice of methodology, it's justified, yes. 8 and 2, the results of the thesis work and obtained using modern methods of scientific research and methods of processing and interpreting data using computer technologies. Answer is yes. And 8.3, theoretical conclusion models identified relationship in partners are proved and confirmed by experimental research. Answer is yes. 8 and 4, important statements are validated in reference to current and credible scientific literature. 8 and 5. And 8.5. The literature sources used are sufficiently for the literature review. 9th, the thesis is of theoretical significant. Answer is yes. 9 and 2. The thesis has practical significance and there is a high probability of applying the results in practice. Answers yes, it is yes. Are the proposal for practice new? Yes, it's partially new. 75% are new. 10. The 10th criterion, the quality of academic writing is high. So, PhD Буранбаев's dissertation on the topic artificial neural network in the monitoring of foundation slabs using a distributed fiber optic sensor was performed at a high scientific level, and we believe that the author, PhD Буранбаева, deserves the degree of Doctor of Philosophy, PhD in the specialty AD07329 constructions. And thank you for your attention.
Okay, thank you, Professor. So, to answer the comments of the official reviewer, Дюсимбаев Изим Насевич, the speech is given to doctoral student Буранбаева Айгерим Муратовна. Please.
Thank you. Thank you for your comments, Izim Nasich. Thank you for your questions. I would like to say that criteria from your comments will be corrected. Yes, I know that some criteria was not useful, but it is correcting. I think it is. It is will be in my future investigations and future researches.
Okay.
Thank you,
Yes.
Igor.
Dear Izim Nasevich, do you have any other questions for the PhD student
thank
or
you.
some remark, comment?
No,
yes?
thank you. I'm not.
Okay. The word is given to the official reviewer, Doctor of Technical Sciences, Professor, Head of the Department of Bridge, Tunnels, and Underground Structures at the Far Eastern State Transport University, Khabarovsk, Russian Federation, Professor Kudryasov Sergei Anatольевич. Please, Professor.
Thank you, Jean-Valat. Written review, official reviewer on dissertation thesis for the degree of Doctor of Philosophy, PhD, Буранбаева Айгерим Муратовна, on the topic of the official neural network in basement slab monitoring using distributed fiber optic sensor. One criteria, the title of the thesis corresponds to the area scientific development state program. Dissertation thesis Буранбаева Айгерим is devoted to the research and new technology in the field of monitoring of the building and the high-rise structure, which made it possible to track damage and the defect in existing structure and the infrastructure. The work obtained and the effective results of the assessing the actual state, the determination structure, which is important for the timely identification of critical values of the defect and the making decision about of the appropriate repair. Due the large number of again infrastructure monitoring the condition of the structure has become of the effective role in the operation, the maintains phase of the structure life cycle management. SHM facilities the monitoring and the assessment structure properties with the optimization the cost of maintaining structure in the improved the safety. Two criteria: importance of the science. The results of the study have been published by author of the free article in local journal, in foreign journal, with percentile of the 74% and 18%, and more than free article in the proceeding of the international conference. Three criteria: the principle of the self-reliance. PhD Буранбаева participate in the loan of the fiber optic cable and the base of the raft under the high air block to measure strength and temperature. The fiber optic cable is attached to the slab at intervals of the at least 2 meters along the length of the cable to achieve calibration length equal to or greater than 2 meters. The results presented his doctoral dissertation and the published scientific papers. 4 criteria: the principle of internal unity. The purpose of the thesis and the objective is clear. The relevance of the thesis is justified and proved by following scientific results. Fiber optic monitoring is possible provided action results the strain in the upper allow of the raft at the lowest level before the high rise 75-story block the building. The compression strain were observed over the entire area of the building, values 20 and 4 mu epsilon. The great values of the compression strain, 4 and 7 mu epsilon, were registered in the center of the direction, the along of the eastern facade of the block air in the building core with some points up to 7 and 8 mu epsilon. The tension strains and the concentrated along extreme axis of the building with the predominance in the southern part of the air block at the walls, the immediate vicinity of the columns in the range of the 20 and the 4 mu epsilon, with separate spots 4 and 6 mu epsilon. Individual patches of the tension strength new columns have been explained by the increased deflection of the raft and the application of the concentrated load. The axis deformation of the 600 mu epsilon or 0.6 millimeters or 0.3 millimeters for change in the crack width are exceeded requires a local diagnostic examination with concrete sampling and the testing for strengths characteristic or part of the diagnostic survey. When the strain about 1000 pu epsilon to 1%, workout basic structure analysis recommended about 1500 mu epsilon detailed on structure analysis is required. Numerical modeling results were core of the building reaction, the settlement of the it's 7 millimeters of the raft surface level. The last settled column around on the core graded 14 millimeters of the settlement, so different settlement to 24 millimeters, and the distance between of the core the last settlement columns is 20.25 meters. With such value settlement difference, the tensile strength of the horizontal plane in the upper allow concrete walls less than 1 mu epsilon. Fiber optic monitoring results at the time testing did not exceed the permitted values for high-rise building operation. However, they characteristic the general picture of the strain in the raft plane, and they make it possible to determine the initial of cracks in the concrete in the early stage. The proposed beam model allows the cooperation with the, all unjoined studies in the building in the quickly response to fiber optic cable monitoring reading. This means that of the will possible to notice the crack in the provide for the location in the drainage in the basement with damage in the fiber optic cable, etc. 5 criteria: the principle of the scientific novelty. The after scientifically substantiated the scientific novelty of the research. The new concept of the integrated beam models with sensors monitoring to improve the visualization and the analysis process of the monitoring, the help to the structure in addition to the operation safety of the building. Recommendation for minimum wedge ledge to the prevent fiber failure. The scientific novelty of the results of Буранбаевой A dissertation is beyond doubt. The after X phases, the user solving such problem as the dependence of the integrated data into the information model in the building on the received sensor data over time. Long-term monitoring buildings faced of real problems is processing large amounts of the data that's a very added to beam model, but this problem was solved is using sensor data in the switching application to dynamic mode. Analysis of large amount of the data was also facilitated by proposed data compression methods of the solver program, missing data to decision making and the understanding for the problem in the complex way. 6 criteria: the value of the main conclusion, the reliability of the scientific statement, conclusion, and the conclusion the applied is beyond doubt. I would like to note the thesis of the consistently desirable the IFU beam reliability to account for static load. Researchers can use dynamic monitoring diagnostic sensor databases of latest situation and the change in structural proposed. This is expected to help researchers better understand the performance is the design loading in the confidence discussion making. It is paper a foundation slab with the embedded fiber optic sensor was considered as example to show that the model facilitate data interpretation using the dynamic beam environment. The development and the use the model concept may result from future research in monitoring the condition of the foundation and the slab packing area of high-rise structure and the solving various problems that arise during operation. The result of the research have been peer reviewed in the highly ranking international scientific journals and have been tested at many international scientific conferences. 7 criteria. The main statements presented for the defense. The after brings the follow provision for the thesis defensive. As a result of the literature view, the after whom the conclusion, the monitoring using fiber optic currently the test solution for the safe building operation. Numerical analysis of the slab extent in determination the minimum gauge length for fiber optic cable of 2 meters for a high-rise building. The differential settlement is 24 millimeters in the vertical direction and the 1 millimeters in the horizontal direction. Development and distributed fiber optic strained wax system of the surface of the concrete raft. Monitoring using fiber optic cable showed the in the central part of the building or in the zone increased load from reinforced concrete bearing walls, compression deformation prevail with in the central, northern and the eastern part of the building, a more stable pattern of the tensive stresses accumulation is observed. 8 criteria. Principle of the credibility, reliability of the source and the information provided. Basis on my comprehensive evaluation and the attest that PhD Буранбаевой has done an excellent job. In her dissertation, she used the following research method: literature review, numerical analysis of slab explanation, modeling of concrete raft and the full load, experimental testing on the construction site. The theoretical conclusion models identified the relationship and the patterns of the thesis as provided and confirmed by the experimental research. However, the comments to the dissertation work is the last subject for the use in the software package to the receive data from sensor and the integrate this data with the beam environment. Also, the after code have suggested how the system with artificial intelligence is supposed to develop in the future. 9 criteria, the principle of practical value. The thesis has practical significance and there are the high probability and applying on the result in the practical. The idea using a fiber optic sensor to monitoring the foundation slab and the obtained data in real time and the integrating in it with the PIM system can greatly facilitate the work of the operating organization and create all the safety condition of the building. 10 criterion: quality of writing and design. This thesis is well structured and agreements are clear. Thank you for attention.
Okay, thank you, Professor. Now, I want to give the to answer the comments of the official reviewer, Kudas Sergey Anatolyevich. The word is given to the PhD candidate Буранбаева А, please.
Thank you for your review, Sergey Anatolyevich. Thank you for your comments. Now I would like to answer your comments. I suggest that this system will be developing, and problem with taking and integrating data from sensors is to be solving because if all components of this system will be open, that's exchanging data will be more easily. And IFC standards helps to solve this problem. Thank you.
Professor Sergey Anatolyevich, do you have any questions, comments, remarks?
No question to Gerim. Very nice dissertation.
Okay, thank you, Professor. In that case, let's start the discussion. All those present at the defense, present colleagues, have the right to participate in the subsequent discussion. Who wants to speak? Nobody? I think maybe somebody give some remark or some speech, some comment regarding to the work.
Maybe I could.
Yes, please.
So yeah, it's really interesting research for me because I am in this field several years in the monitoring, in other monitoring system, and on the other hand, I have no any idea about fiber optic system in the monitoring. So it was something new for me. When I written your research, I have a moment desire to input some fiber optic system in our slurry walls, in our concrete system, but I was and I was surprised that it don't work with the water. And you said that it doesn't work with the in the water environment. So in St. Petersburg, underground construction in the slurry walls and the some deep foundation, we have water at all. So it was something new for me, and I was surprised that it's a new field for you, Aigerim, and of course it was cool, and I of course want to say thanks for the chair, for the Asel Sirikovna, for the members of this dissertation soviet, and of course for the Askar Jakparovich, for the professor Sergei Anatolyevich. Many thanks for the day, and Aigerim, it was cool research. Thank you.
So thank you, Ivan Pavlovich. So does anybody want to give some speech about the dissertation? If nobody, I want to say that this work is very interesting, because one time when I was in Abu Dhabi Plaza, you know, it is under the ground about 20 meters. It is 4 floors, and it was really about maybe 5 or 4 years ago, there was really the problems regarding to the underground structures, the walls, the foundation, especially from the walls. There was some water infiltration to the underground side, and the sewage system of the underground is not so good working, because the water infiltration is very high. A lot of water come, and the pits is every time is filling, and the pumps is every time working. The power of the pumps is the number is also was not enough. So during this time there was a big problem, and I remember that I begin with the work in this time. The professors from Malaysia, by the propagation of the Professor Askar, come here in Astana, and I was on the lunch with these professors, and we was in this construction site, and in the underground I see I have some big chance to be under the ground and see this situation with deformation and with the cracks, and it was very interesting for me, because and also I want to say that Abu Dhabi now is the highest building in the Central Asia. Very interesting, and one of the, for Kazakhstan, I think it is a big big project. One of the first biggest project for the tall high-rising buildings like this. And I think the fiber optics technique is used first time in Kazakhstan, especially in this object, and very interesting results. It could be more interesting if you give some more information about how the location of the cracks and the parameters of the cracks, and why you choose to putting this depend on the cracks, and how the connection between these deformations and the location of the monitoring systems, and some comparisons will be more better also. But anyway, this topic is very interesting, and one of the first topics, and I hope in the future some another PhD students will continue this topic. Okay, thanks.
Thank you.
Maybe now somebody want to give some comment, some speech.
Dr. Jambulat.
Yes.
I want to say very few words, especially for, I remember Professor Diakonov gave some questions for Aigerim regarding of geodetic monitoring of some differential settlement of buildings, because different campus, different facilities. Of course, this is another company inside of Arabtech has some independent company, geodetic. He control of vertical settlement and inclination of this high-rise building, of course. But IGRI more concentrated only for special sensoring monitoring, because no time, is the duration of life, study life only 3 years, so not so easy for make some another additional work for geodetic, because geodetic is already done and already made by another independent company, a very high level company, professional company. So now we have very good vertical directions of our Abu Dhabi Plaza. So I think this independent company also work very well. So this is my small reply or small comment for questions of Professor Diakonov.
Thank you.
Okay, thanks very much. So no any discussion more. Okay, if nobody want to participate in discussion, I want to continue. Thank you. The next word is given to the scientific secretary, Asil Serikovna.
Okay, thank you. So, the members, reviewers, please conduct a secret. What? We start a secret ballot, yes, Professor Rambulat Shahmo?
Yes.
Okay. So, to conduct the
Begin.
secret ballot, it is necessary to select a PhD candidate Буранбаева А. From the list in the Smart YNU system, click the Defend button. After that, the voting window is open. You need to download the voting password, then choose one of the options. Click the Vote button. So, please now, I'm going to start voting. So, please wait for 1 minute. So, now you can start. So, dear members, dear reviewers, please.
Okay.
In the left side, you can choose dissertation council. After that, please choose PhD Буранбаева.
Okay.
And you have several options. The first options to agree for award Doctor Philosophy of PhD. And after that, you can see another options.
What is it, the options?
What? Excuse me, Professor Юнусевич? Выбираете диссертационный совет.
I forgot, where is the, where is the, I don't see.
Smart YNU KZ, потом Dissertation совет, потом Буранбаева Айгерим. Вверху такая зеленая кнопочка горит.
Вверху такая зеленая кнопочка, как щит. Как щит воина.
Гладиатора Спартака, да? Гладиатора Спартака.
Да.
Так, профессор Шахмов же был, excuse me, already done. Дьяконов Иван Павлович, Дюсимбаев Изим Насевич, Котов Павел Игоревич, Professor Admum Buminat Khan already has done. So please, Dinara Kazbekovna, Sergey Anatольевич, and that's all. Please, I wait you, Dinara Kazbekovna and Sergey Anatольевич. Just a moment, I again check your voting. Dinara have already done, thank you. So please, Professor Kudryavtsev.
Сергей, получилось, да?
Professor Kudryavtsev, if you have
Слышно,
problem, please
микрофон.
ask me.
Микрофон. Сергей, открой микрофон.
Асия Сергеевна, у меня получилось, да? Посмотрите,
Получилось,
пожалуйста.
получилось. Я говорю,
Сергей
это только
Анатольевич,
Сергей Анатольевич.
микрофон надо открыть. Сергей Анатольевич, микрофон свой открой.
Я все проголосовал.
Сейчас проверю,
Там
please.
9-7 пока. Кто-то двое еще не проголосовал.
Все правильно. Сергей Анатольевич, вы проголосовали. Спасибо. Так, пожалуйста, одну минуту.
У тебя под контролем все, но тебя не
Сергей
скроешь.
Анатольевич, да, все хорошо, спасибо. Минуточку, пожалуйста, уважаемые члены. Я еще раз проверю, получила ли я все голоса. Сейчас, момент.
9-8. Еще кто-то, еще один.
Okay, already done. So please now I show you the protocol of voting. So please wait 1 minute. Just a moment, please. Now I share my screen. So please, dear Chairman, Professor Shahmov, could you please read and or give speech for one member to read the decision of voting? Professor Shahmov. Professor Shahmov.
Yes.
Can you view my screen?
Yes, I see.
Okay, thank you.
The composition of the Content Commission, please vote. Yes, who agrees? So everybody. Against? No. Abstentions? No. Adopted anonymously. So voting protocol. So, Сесегна, я читаю, да?
Yes, you can read by yourself, or
Yes.
please give a speech to one member.
Okay.
I think if you read, it's okay.
Okay. I want to read regarding to the so the protocol of the commission is approved anonymously based on the public defense reviews of official reviews and the results of secret voting. The dissertation council in the direction of preparation 6D073 architecture and construction, in specialty 8D07329 construction at the Eurasian National University Alan Gumilev, decides to award the degree of Doctor of Philosophy PhD to Буранбаева А in the specialty 8D07329 construction. And regarding to this, let's move on to the discussion of the draft conclusion. Each project has will the members of the dissertation consult the reviews of the proposal, comments on point 17. Comments on, yes.
It means point 81.
81, yes? Okay. Okay, point 81. So, firstly, nature of the results of the dissertation. We have 3 points. First point, it is theoretical provisions, the totality of which can be qualified as a new major achievement in the development of the relevant scientific direction. Second option, solving a scientific problem of significant social, cultural.
Dr.
Yes.
Jambulat,
Yes.
I think it's 813.
Yes, okay. 813, yes. Scientifically based technical, economical, technological solutions, the implementations of which makes a significant contribution to the acceleration of scientific and technological progress. Number 3. Okay. The next point, the level of the novelty of the results of the dissertation. We have 3 options. The results are new, some results are not new, much of the results are not new.
822.
Some results are not new, yes?
822, second one.
Okay. Next question, the value of the results of the dissertation, high, satisfactory, and unsatisfactory. What
Голос надо открыть, микрофон надо открыть, да, вот Изим Васильевич хочет сказать.
It's high.
Какой, Изим Васильевич?
831, it's high.
831, okay. 831, okay.
Okay, yes, everybody agree?
Yes.
Connection of the dissertation topic with planet research. We have also 3 options. The topic is included in state and regional scientific and technical programs and international research programs. The topic is included in the program of fundamental research industry program plans of the scientific organization and higher education institutions. And number
842.
842. The topic is included in the program of fundamental research industry program plans of scientific organization and higher education institutions. And last one, the level of implementation of the results of the thesis of applied value and recommendations for the expanded use of the results of the thesis of applied value. 853 industry-wide. Yes?
Yes.
Okay. So if no any questions, yes.
Dr. Jambulat, what is voting results? I don't understand.
The voting results, regarding to the voting results, 8 members is voting for defense, like here, for giving the defense of the PhD doctor. No any voting for reprocessing. No any voting for another for new defense for the petitions. Yes. 8 voting for giving the PhD without any corrections or repetition. Next one. If you are not argue, I want the final word give to PhD student.
Agirim, your final words.
Oh, thank you. Sorry. I would like
not last words, it's final words, final.
Okay, thank you. I would like to thank all of you. Many thanks for taking time for thinking, and I would like to thank my supervisor who searched all of time, Professor Askar. He was the only who believes in me and my work, and I would like to thank because I learned a lot from Professor Askar, not just my research work, but only in my life, and I really enjoyed the research experience with him, with our team. Also, I want to thank all the staff, Geotechnical Institute, our Eurasian National University, for helping, for hoping, for believing for me. Thank you, Zimnasevich Sergei Anatolyevich, for your reviews. Thank you. It is very important for me. Thank you, Seserenko, for organization and supporting for me. Thank you, all members, for your attention. Thank you.
Thank you. Congratulations on your successful defense. I get him.
Thank you, Rahmet. Okay.
Yes.
Yes.
Rahmet.
Congratulations. Thank you.
Yusuf, meeting in Astana. 76.
Поздравляю с успешной защитой.
So, thank you.
Next meeting will be 17th Nation Regional Conference in Astana in August. So welcome.
Yes.
So we have 1,000
yeah.
registered people, about 1,000 from 90 countries. So big international typhoon coming to capital of Kazakhstan. So we will wait for beginning from airport. Special people will be with musical ensemble will be beginning from airport. And wait very big VIPs, international people from 90 countries. With Kazakhstan, Dombra, with beautiful lady, with Kazakh kimono. Kazakh kimono.
I like it.
So, thank you, Professor Oscar.
Welcome reception will be 14 August. Akim, governor, mayor of city will be invite full delegates, 1,000 people for hall, because we no room for accepted this big delegation. So we accepted in hall of Hilton Astana Hotel with nice horse meat and horse milk. And of course, in the little Russian vodka, because we have next day. And also we have some dancing, multiple dancing, beginning from Kazakhstan and ended of Ukraine and Caucasus, no problem. And
Thank
will
you,
be
Professor
gala dinner, final day, gala dinner. Technical tour to Almaty, also technical tour to Kyrgyzstan. So I invite of members of council meeting of the defense dissertation committee pay of registration fee. Deadline is first March. You can pay by credit card. So now civilization come to Kazakhstan, not only bank, by credit card. You push from card Mir or Visa or MasterCard or American Express, some different Sberbank, National Bank, International Bank, and money come automatically to Kazakhstan. And you will be provided our service from us. Good food, good reception, and good enjoy of scientific time and also social activity in Astana, Almaty, and Kyrgyzstan. Issyk-Kul. Welcome.
Okay,
So
thank you,
finish,
Professor.
да?
Yes, no, I would like to end our meeting. The meeting is closed. Congratulations for Aygirim. She finally defend her thesis. So thanks you all for your participation. So good luck, good health. So thanks for organization, for Asel Serikovna. Great job. So thanks a lot.
Dr. Jambulat, don't forget send you lecture. Don't forget your last lecture.
Okay.
You not send you paper. We wait. You know, Asel Serikovna Sarsemboyeva, you very strong lady, general secretary, very hungry.
Okay, I understand. I'm sorry. Okay. So thanks a lot from Almaty, Kazakhstan, from Russia, for your participation, and great honor to be here with you. So good luck. Thanks from the Pavlodar, we have the Dinara. I didn't see her a lot of time. Now I see her by video. I think her okay in Pavlodar. Good, beautiful city also. So
Благодарю.
thanks a lot for participation.
Dinara became more beautiful now. Dinara became more beautiful.
Yes.
After PhD, after high-level associate professor, and became very beautiful there. More beautiful than before.
Thanks, Dinara.
Thanks.
So
Thank
see you.
Thank
So
you.
see you.
Thank
So
you, Bumi.
good.
Thank you, Bumi. Professor Bumi, thank you very
Professor
much.
Bumi, yes, also thanks. Okay.
Thank you. Bye.
Best regards to Delhi capital.
And also sitting with us, Dr. Dania. Yes.
Dr. Dania, yes,
Postdoc,
she very
yes. She
active.
is also with us.